ora tātou. As I said earlier, just help yourself to the kai even when we do our presentations. Just pop up and have some kayaks there for you all. Kia ora tātou, here's Don Way on the board. He's come this evening. Here in Mihi Karakia. I'll say a brief mihi to welcome you all to the hui and the Karakia to commence us off. Kia ora mai o tātou, e hui hui mai nei tēnā koutou katoa. Haere mai e ki te hāpuri o te roki, so welcome to your local community, ki tēnei hui o te pō to this evening's hui. Ina ka wātua wana nui a tātou, to our respected elders, tēnā koutou. Ina reo, to our speakers here, to the mai o tātou, acknowledgement to you all. Te kai mahi o te papa atu pai, members of the Department of Conservation, tēnā koutou. Ina member o Zero and Basic Predators, tēnā koutou katoa. He te piri hi mana, to our local constable, ki au koe Stewart, tēnā. Hoi anō tātou, I tēnei hui, I tēnei pare, o te runga I te motu o Rakiura, tēnā koutou katoa. Te karakia e te tīmata e te hui, a pēr te kumese a hui. Whiti ora ki te whai au ki te aumāraka, whiti ki runga, whiti ki rāru, nune ki te pōhatu, nune ki te rākau. Te taha ka tēnei taha, ke taha ka tēnata, tihei mai hui, kia ora mai o tātou. So welcome to everybody this evening. Thank you for taking the time to come to the hui, to our kaupapa hui, 23 Rakiura, and an update of some of the monitoring that we want to share with you from the treatment for the dotterel habitat that was held some months or some weeks ago. We have our speakers here, and the first speaker up will be Darius Fager from Zero and Basic Predators. Our next speaker will be Tristan Rawlins from the Papatawhai in regards to the treatment of 1080 to that habitat. We also will have a Pukenui update from Grace Tocker and Jen Ross from Te Papatawhai. And also I'd like to welcome Nathan McNally from Te Papatawhai as well. Nathan's sitting over here. He's the man with all the answers, I believe. However, if we could move on to the agenda, just a couple of things to take note of. Of course, as we manaki ourselves here this evening and taking care of one another in respect of the safety process, the exits are the front doors, the social room and the bar stadium. The first aid kit opposite the manager's office. Fire extinguishers from the kitchen and the foyer. Defibrillator, once again, hopefully we don't need to use that in the foyer beside the manager's office. Fire evacuation by the weather station, and tsunami evacuation trail park, and also at the end of the hui there will be question time, but also after the hui is completed with the speakers, then we'll open it up for the questions. So the important part is that the speakers have that opportunity to do their presentation, and then again, once they've all completed their presentations, that's when we'll have the question time to keep things moving along. Also, something to remember as well as a Manaki code of conduct within ourselves. It's really important to keep ourselves respectful for one another and to keep to the point for all the time in regards to, particularly when you ask a question, if you could keep it as brief as possible. You may want to mention your name as well when you do answer the question. Right. So I'll hand over here to Darius to be our first speaker this evening. Kia ora tātou.
Good, and thank you, Tane. And just a couple of other things on the hui this evening. We do record all these hui, and we put the sessions from the presentations up on our website so that they're available afterwards, and people who aren't here can view them. We don't put the Q&A session up there. We want people to be able to be free with their questions there, so we never put that part up online if you're worried about that. So kia ora, I'm Darius. I'm the General Manager of the project working with zero invasive predators. And I did also want to add, we will be at the museum tomorrow morning. All of the presenters here, if you want to come and spend any time tomorrow morning between 8 AM and 10 o'clock to have a more in-depth audit, if you're free. So I'm going to go through a little bit about how we did the recent operations, and then Tristan's going to talk about the monitoring. But really, this is what we're here for, these species here, and some others like the dotterel, the pukanui. Some are doing okay, like the kakariki, but we know that tiaki, mohua, and kakapo can't really exist on the island. And then also, we are here for the forest, and giving this forest a better chance at health, and we'll talk about that a little bit later. So just to recap, I thought I'd walk back through a couple of things that people may not have picked up on or hadn't been to previous meetings. Our original idea around starting the predator-free Rakiura project was this image on your left, which was to start at the bottom of the island around the Pegasus area and do a eradication trial in that area and then progressively move through the island. When we started planning this, we obviously became aware of the situation with the pukanui, the southern New Zealand dotterel, where we got down to around about 100 birds, 105 individual birds, and they're getting very close to the extinction because of mainly the gender imbalance in the breeding age population. And the pukanui, breed in the centre of the island on some of the high peaks, and at some of the other high peaks around the island. So we thought the best chance we could give pukanui is to work with the Department of Conservation and do a suppression operation, which is in this blue area here, instead of starting our project at Pegasus. Because it wouldn't have made a lot of sense if we were working down in Pegasus and we had a species go extinct elsewhere on the island. So that's essentially where we got to. Before we started the operation, we built these gantry cranes out at Island Hill in Mason Bay. There were two of them. They built on a wooden platform, and essentially these cranes were built to help us load the pre-feed and the 1080 pellets into these hoppers that the helicopters then use to distribute the bait in our operational area. We built two cranes, obviously, because it was quite a large operation when we got to the Pukanui area, which was around about 40,000 hectares. And these gantries and gantry cranes were dismantled after the operation and taken off the island on the 23rd of August, but the platforms are still in place at Island Hill. That's essentially how that system operates. Each one of these bags in these boxes weighs about 300 kilos. They get pulled up onto the crane and then shifted over into the hopper that the helicopters lower onto the ground so that it can be filled. So that's why we needed a system like this. And this is something that we had to do because we were operating on an island. We bring the bait to the island, have it in place, and then load it into the helicopter hoppers using the system and the crew that you see on the ground there. So the first thing we did is, within that larger area for the pukanui, we started an eradication trial. And the eradication trial was in a smaller area of around about 7,000 hectares in the Rakiura area. And this involved 2 non-toxic pre-feeds, followed by one application of toxic bait. And there's two colours in here. The pink area representing the area where we use deer repellent in the eradication trial, and the blue area representing the area we didn't use the deer repellent. We did the two pre-feeds of the non-toxic bait on 16-17 June and then 26-27 June for the next pre-feed. When we brought the bait to Island, we mainly unloaded up here, Mason Bay. We did do one unload from tucked in behind Ernest Island there, and we did one pre-feed unload from Southwest Arm because we had to bring bait over from the mainland in the wooden boxes that protect it while we're shipping it over the sea. This is then what the toxin application looked like. So again, a deer repellent bait area and a non-repellent bait area. And there's a lot of information when we're doing these operations. So it's not random. We give our pilots and any operator a very clear plan. They fly to that particular plan and we monitor it in real time throughout the operation. And we can monitor it in quite a lot of detail. So this picture on the right, your right, is actually showing the height that the helicopters flew at. Because this was an eradication trial and we wanted to get as even and thorough coverage as we could, the helicopters essentially follow the landscape. And you can see the red areas where they were flying above or over the canopy on hills or mountains. And the blue or the dark blue areas are where they flew lower because of a valley or something that was closer to sea. And so we get this information coming through as we're doing the operation, and we can give feedback or communicate to the pilots if we need anything to change or adjust. Then after we did the trial, the eradication trial area, we then did the bigger Pukenui operation, which was around about 40,000 hectares, and we broke it into these blocks. The blue blocks representing the hunting blocks where we did deer repellent, central area which we call the northeast block, and then what we called the southwest block. To do an area of this size, we did the pre-feed over 3 and 4 August. That took 10 helicopters, 7 to fly bait and deliver the bait, and 3 helicopters to move fuel, equipment and people in and out of the operation. And so that's quite a lot of activity, but it's very important for us to try and get the bait on the ground as quickly as possible. So over a 2-day period we covered the 43,000 hectares for the pre-feed, and then on the 21st and 22nd of August we did the same area again with toxin or toxic bait. And essentially that image shows the flight lines. So the helicopters would come out of Island Hill and then essentially, for the most part, fly in straight lines across the area to give it a nice even coverage. We did the repellent blocks. Usually we did them first and separately to the areas without deer repellent. And like I said, each of the helicopters carries a little data recorder. When they return to site, they give us the stick that's in the helicopter. We put that in a computer right there, and we can see exactly how much bait has gone on the ground, where it's gone, and exactly where that helicopter went in real time. The pilots that do this take it very seriously, and they want to know they're doing a good job, and it's important for us to keep them up to date during the operation. Also in that operation and throughout, we had a coastal buffer of 150 metres. We did this because we'd been talking with the fishing industry, and we thought for the purposes of the Pukenui operation and this eradication trial we would have this buffer. And essentially you can see an example of that in here, where to achieve the buffer we flew around the edge of the areas to get an accurate 150 metre buffer off off from the coast. I walked into, this is in the Doughboy area, I walked into that after the operation, and yeah, we know for certain that that bait was at least 150 metres from the shore, if not more. We did that for the deer repellent and non-repellent areas. This is an area of the coast where the deer repellent and non-repellent areas intersect, so you do that coastal buffer there with the different types of bait. Just so you can see that. And then to give you another idea of just accuracy in some of these tricky areas, this is then, I like this picture because we've got this little peninsula here, and you can see how the helicopter can even get into a fairly thin peninsula there and deliver the bait accurately. It's really important for us to do that with a high degree of precision, particularly in an island, because we only bring a limited amount of bait over to the island at a time. We only bring what we need to do the job. So we can't deliver it any heavier. We have to be accurate because we don't want to run out, and we certainly don't want to miss any areas, because that would be a problem for our coverage. So it's very important that we get good coverage and spread the bait evenly and quickly. So again, the toxic delivery took about 2 days. It actually took about a day and a half. And we want the target animals, the possums and the rats and the cats, to be exposed to the toxin at pretty much the same time. We don't want differences in delivery time because that is the most effective way to make sure that the bait does what it's supposed to do. So I'm going to pause there. That's just a little bit of a walkthrough of the operation. I'm happy to talk to anyone about that, and I'm going to hand over to Tristan, who's going to talk about our first monitoring information.
Hi everyone, I'm Tristan. I'll just take a bit of time to introduce myself. So, and how I sort of ended up being here talking in front of you guys. I started in Dock as a training ranger. I left school a bit early and decided I wanted to work outside. And I did my cadetship for a couple of years in that program, which at the time was the Modern Apprentice scheme. And then I was lucky enough to get a job on the 28thOct for 3 years on the carpet ball recovery program. And that's quite a cool program that kind of blended conservation and science, and I found it quite inspiring, but sort of left that job going. I sort of really need to be able to explain what I see in the field in a kind of scientific way. So I went to uni for a bit, and after that I started working for Dock. Again, looking at the costs and benefits of 1080 on different species, and I was pretty excited about getting that job because I really didn't know much about it, and I wanted to know what all the fuss was about. And so I sort of ended up working on a whole bunch of different species, which I changed the slide. Here's me, and sort of what the costs were to be killed any of the birds we were trying to protect, what the changes in the nesting success was afterwards. And so I ended up doing a whole bunch of different studies. So I worked on Morbo, Kaka, Weekers, Robbins, Rifleman. And then I actually went to uni again partway through a study on rock greens. And so my brief on rock greens was we hadn't used 1080 above the tree line before. We wanted to see if we could control predators in the alpine environments and whether we could turn things around for rock greens, because they were becoming I wouldn't say nationally endangered, but there was lots of local extinctions happening, and their range was constricting to the central southern Alps. So I did a study on that as well, which is pretty cool. And yeah, so my job now, the bulk of it is, I'm checking notes here. I should know what my job is. Is delivering the kind of research around Dock's 1080 program. So we're sort of integrating what we find out into what we're going to do, and I've got a big part which is designing and analysing the data from the monitoring that happens in all the 1080 explain what adaptive management is, and this is kind of the cycle that we're in. And Tina hates this slide, so I put a bit of a key in it for her. Basically we have recipes for predator control using 1080, and they're not recipes as in we make different bait formulations up, it's the way we apply it. So it's what time of the year we apply it based on what's happening in nature. So like whether there's a mast coming, whether there's seed on the ground, whether the seed's just germinated, whether rats are growing or the populations are growing or falling. So we have all these kind of situations where we have different ways of applying bait. On top of those situations, we have a bunch of different species, and so different species need different levels of predator control. So some of our really sensitive things like mohua and rockweeds that are really sensitive to rats, we need to stop rats getting to the great number. And we have other things that are really sensitive to stoats, and so we want to make sure we don't end up in a situation where we've got lots of stoats, the rodents crash and the stoats get desperate and nail things like carcass and Theo and cats. So we've kind of got these different mixtures of things that we do. We've got a national budget, and this all kind of goes together, and we have to make some really tough calls about where we're going to apply poison. So I think DOC is meant to manage about 1/3 of New Zealand, and currently we treat about 10% of it with 1080, so we're pretty low in the areas we manage. So you could argue that we don't manage more of the conservation estate than we do. So once we prioritise where we're going to do things, we deliver the operations, and then most of my job's over in this bit over here, which is the research and monitoring, and then publishing those results, evaluating where things are going right, where they're going wrong, changing tack, and then we feed that back into the management prescriptions, and round we go again. So Rakiura fits into this. That's the next slide. From a pest perspective, on the mainland, we know a heap about stoats, possums, ship rats, 28thOct, tracking tunnels. That's the bulk of that kind of knowledge on the pest front. And we've just started moving into trail cameras because they've got reliable enough that we can do some quite cool things with them. Rakiura is obviously pretty different to the mainland. We've got cats as a dominant predator on the island. And we've got limited experience understanding the effects of secondary poisoning on cats. So when I talk about secondary poisoning, cats aren't eating the cereal baits, they're eating rodents or dead possums or whatever that become toxic through eating the bait. That's the same way we kill stoats. Stoats don't eat standard cereal 1080 baits, they eat the rodents that have been killed by them. On Rakiura, we've got 3 different species of rats, and they're all dominant in different habitats. Whereas on the mainland, we're mostly dealing with ship rats, and it's kind of an interesting look back in past on Rakiura. So back in the late 1800s, we used to have Norway rats on the tops in the Southern Alps. They were the dominant alpine rat, and with the introduction of stoats eradicated Norway rats from the tops, and so that's why we've still got them here, but not on the mainland. So so we've got these new tools, trail cameras, which we're using quite a lot, and I've had a big project over the last year trying to calibrate trail cameras with some of our more established methods of monitoring, like rats tags, residual track cache for possums, tracking tunnels, and we kind of place that old learning with the new methods with tracking tunnels. So this is a pretty exciting time to be working in pest management at the moment, because it's the first time I've had a single tool that we can monitor a whole lot of different animals with. So I just thought I'd run you through another map, which is kind of all the things we need to consider with this operation. So the red outlines are all the recreational hunting areas, the blue bits are where the Kukanui breed. We got this 2-phase area here that Gary has talked about before, where they did a 1080 operation prior to the second one, which is this big 40,000 hectare job here, which came over the top of it a month or so later. The orange areas are the bits where the treatment area intersected with the hunting areas, and that's where we used the repellent bait. So we'll run through all the monitoring infrastructure on the island. So Zip have got these rat grids in here in the 2-phase area, and that's to tell the story about how the 2-phase area has gone on rats. for the two-phase resetting, I guess you could call it. So we're also monitoring deer, and so we've got 3 grids for deer. We've got one in the deer repellent area, one in the standard 1080 area, and one in the non-treatment area. And the hunting leadership that is sitting in DOC were negotiating with wanted an independent deer study. It was independent of DOC, so that data's been analysed by Rakiura Research, and I'm trying not to have hurt feelings about it. So the work that I've been involved in is these next 2 grids. So we've got these rat grids here, which are really similar to the zip grids, and the reason is we want to be able to tell a story of the difference between the two-phase areas and treated and untreated areas with and without deer repellent. And I've been involved in the cat grids. So the cat grids are at a much wider spacing, and they're looking at a bait. And we're using the methodology developed by DOC's National Eradication Team. So they've been putting a lot of work in over the last 6 or 7 years looking at feral cat control and eradication, building up to the Auckland Island eradication. So we've got a really good steer from them about how we can best set up this cat monitoring. So those are our cat grids. We've got the non-treatment one up at East Rogity, and then we've got this big one running from the coast and over the Tin Range. And so there's 2 big questions that we're wanting to answer for this, which is firstly, do we get a good kill of cats from this 1080 operation? And if so, how long does it last for? So how long does the bulk last until we see cats re-established to the levels pre-treatment? So those are our 2 big questions. Hopefully that was a bit better than just showing that slide with all the monitoring that's happening on the island for this op. That's pretty gross to look at, but what I do want to make the point is, from an introduced mammal perspective, this is the most well-monitored 1080 operation that's ever happened in New Zealand, and that's a pretty cool thing to be able to get up here and say. Yeah. So these 2 grids, that's our zoomed-in one at Doughboy, or at the Tin Range, or everywhere in between, and that's the one at East Rogity. So we did fairly well at getting them out in a pretty good grid pattern. And to give you a sense of scale, this is about 3/4 of the way through the Doughboy grid. So there's still about 2.5 k's of cameras behind us, and it's about 10 or 11 k's out to the coast. So we've got a camera all the way through there every 450 metres by 2.5 k's wide. And it's not the nicest country you've ever been in. So yeah, it was a fairly solid effort, and I was pretty chuffed that we managed to pull it off. So I've been to about half the cameras on that grid, actually doing the work, and yeah, it's been quite an interesting experience. Got quite a lot of rich terrain here. Yeah, so the camera setups look like this in the forest. So we've got the trail camera here. They're all 700 mils off the ground. And then it's somewhere between 1.5 to 2.5 metres to the bait, which is down here. And the idea is that they're put in a sort of place where animals are naturally moving, so going trails or things like that, just so we're getting animals that are casually walking past as well as ones that are interacting with the baits. When you get on the tops, obviously there's no trees to attach things to. And so we're looking for areas where we can afford the camera some natural protection, but also places where cats are likely to be sitting because they're trying to shelter from the same kind of weather that we're trying to shelter cats from. Yeah, so we put them on these plastic waratahs where we could, and sometimes there's just not a lot around, and the waratahs would just blow around in the wind and take lots of photos, so sometimes we attach them to rocks. So that's a different version of the setup. The baits look like this. So we don't put a kiwi in front of every camera, but they're these rabbit baits which are on a little wire hoop, and it's fresh rabbit, and then there's 2 terracotta balls which are a little bit hard to see under there, and they're soaked in this oily rabbit juice stuff which you buy from Conservation, and that seems to hold its scent and smell fresh for quite a long time where the meat baits go off. And so we use the baits in front of the cameras to increase our probability of detection. And so the way to explain that is we're more likely to see a photo of an animal if we put a bait in front of it than if we don't. What it doesn't do, we don't make calls that there's more animals out there. It's just we want to be really sure that we're looking as hard as possible. Yeah. So I just have to do a little plunky thing and drop out the slideshow for a sec and talk to you about how we deal with the data. So one of the projects I've been involved in is working towards building an AI image classifier. So there's a couple of guys in my team that have been working on this. One of them's like me, he's a scientist in the team, and he's found this like geek that's really good at computer programming and does like competitions online to make AI things and loves Star Wars and that sort of carry on. So he's made us this image classifier, and there's a little bit of misconception about how AI things work. You don't just like ask the internet to tell you what the picture is. We've actually built up this huge image library of pictures from trail cameras that someone like me has gone through and said, that's a cat, that's a rat, that's a possum, and we use that to train the detector. And there's a whole lot of tricks about how you make it better based on the images you have. But there's two numbers on this that are quite important, and I'm going to run you through a typical encounter from the camera with a cat. So the box drawn around the thing is by a program called Media Detector. And I'll just point out you don't have to understand this to understand the rest of the thing, but for people that are interested, I think this is pretty cool. And that 0.9 is a score out of 1. So that, if we think a bit about how sure it is, that means it's 90% sure there's something in that box. And then the number on the left, 0.73, is how sure it is that it's what it says it is. So that, for example, is 73% sure that it's a cat. Right? So when a cat goes in front of the camera, you don't just get one photo of a cat as a rule, you get quite a lot of photos. So this encounter we'll get to might have 20 photos. And I don't want to count that that's 20 cats, because it's not, it's one cat that takes quite a long time walking past the camera, and that's the same as one cat that runs in front of the camera, we only get 2 photos. So we've got this next rule that we incorporate into our analysis, which means that if you take a photo of something, the next photos of the same thing, and it's within 5 minutes, that counts as one encounter. And that resets every time we get the next image. So if you say get a picture of a cat every 4 minutes and 55 seconds for 2 hours, that counts as one cat, not whatever the maximum number of cats there are. The final bit of that is you set this level that you're happy with the confidence. So for cats, I don't use something that's 0.73. My threshold is 0.97. That's 97% sure it's a cat, because occasionally it gets things wrong at any score under that. And so we have to discard a little bit of data. And what you might think is that means that we're throwing away images, but we're not, because what happens is, let's run through this cat. So this is one encounter, so I would throw away that picture, I would throw away that one, I wouldn't throw away that one because that's really sure it's a cat, wouldn't throw away that one, I'd just lift that one, that thinks it's a mouse, I have no idea why. We throw away all mice that are that low down, that's just the way it is. And so you end up discarding pictures, but you don't discard encounters, because for most animals, when they walk past the camera, we get high confidence detection because we get multiple images. And so when we chug through this, you can see that we get quite a lot of photos. Most of the time it gets it right. And as long as it gets one photo within this burst, that's the last photo, that's one cat. Doesn't matter about the numbers we discarded, the images we discarded, it's always going to be one cat. So that's how we kind of deal with this huge volume of pictures, is by kind of making these rules, testing them, testing their assumptions. I went through all the cat images from the first few surveys to test that assumption. I didn't throw away any data, I just threw away images I wasn't sure about. And so that's the kind of world we're living in now with this camera stuff. So I'll start this again, and unfortunately it goes back Cool. So results. This is the results for cats prior to the 1080 operation. And this is for the entire, it's about 3.5 months from when we got the grids installed to the day of the 1080 operation. As we run through these, I'll explain the first one well, and then hopefully it'll make sense from there. So the scale's up here, which is how big the blobs are. Be aware, the scale of the map is slightly different, but the scale of the blobs is not. Everyone thought it would be better to have the non-treatment on the same slide, so that's what we've done. So you can see the biggest blobs up here are sort of 2.5 to 3 cats per week, and the smallest ones are 0.1 half cat per week, which is probably seeing a cat once, and then the next size up is you're seeing a cat every 2 weeks. That's kind of how we've done it. Yeah, so that's what things look like beforehand. Yeah, we had a few cats on the tops, not heaps. That could be seasonal, I'm not sure. And as a rule, the non-treatment actually has more of everything than the treatment. And so that's different, but it's the trends over time that we've got to look at. So it's a nicer place to live up here, and it's also a nicer place to run a camera. The forest is much nicer. So yeah, so after the operation, this is for this period here, which is about 6 weeks. So that's from the day after the 1080 operation through till the 8th and 10th, which was that 18 days ago. Yeah, you can see over that same time period, we've still got quite a few cats in the non-treatment, and we've picked up 2 cats, or 2 detections of cats, or 2 encounters, I should say, of cats in the coastal exclusion at Dover Bay. So let's just keep thinking about these 2 cats here, and also think about the fact that I said the cameras were baited for a month. So this is what this looks like in a different way, and I forgot to explain this. So all these cameras that are in this coastal exclusion form the coastal exclusion chart. All these cameras that are inside the treatment area form the treatment chart, and these ones here form the non-treatment. So that's about 55 cameras, that's about 100 cameras, and it's about 7 or 8 cameras. So that means this estimate's based on about 7 or 8 cameras, this is on 50, and it's on about 100. Every dot is a day for all the cameras in that group. So that's a day for those 7 or 8, that's a day for those 50, and that's a day for those 100. So you can see that in the coastal exclusion, a lot of days we were getting no cats, some of the days we were getting a cat, and occasionally we got a couple more. This is not a great demonstration of the baiting and the control it is. So you can see in that month, we put the cameras out with fresh bait, we came back 2 weeks later, we replaced the bait, all the SD cards, and then we left them running beyond that period. You can see in the first survey and the second one that we get more detections of cats. Doesn't mean the population of cats went up here, it just means it's more sensitive. This is the problem with baiting cameras, is your bait sort of has a bit of an effect. But what it means is in the non-treatment, we've got a higher probability of detection in this period, we're more likely to detect cats. When we get to the control area, this means we've looked really bloody hard in here compared to this period, and we haven't found any cats. These 2 cats, the detections here, were in the week following the op, and we haven't seen them since. So we haven't seen any cats on any of those cameras in and around the treatment area for 5 weeks now. So I'm really chuffed about that result. I didn't actually expect it would be that good. So that's pretty cool. So I feel like we're moving to we definitely moved to the point now where we know the tool we've used to control cats is the right one. It's worked really well. And we need to see whether we've got the size of the block right and how long it lasts for. So that's the next piece of the puzzle. So these cat cameras will run again, so they're running now. We'll rebate them in early November. Do the same thing, bait it for another month. So we'll do the first baiting, we're going to change it 2 weeks, and then leave the cards in there through to March, and we'll run the same program. When we see the results from there, we'll make the decision about how much longer we carry on, but at this stage I'd say we'll be into next year as well. So that's the plan for those. Next up, we're going to look at possums. Possums are quite interesting. You see the scales changed here. So there's possums that are more common or more happy to go in front of cameras than cats are. See these blobs here are sort of 10 to 12 possums per week. Possums really don't like the tin range. Yeah, it's pretty wet up there. I think that's probably part of it, but yeah, we didn't detect any possums on the open tops at all. And you can see again that the non-treatment's got some like pretty big blobs. Those are sort of 18 possums a week. So yeah, quite similar, the two sites. And this is after the 28thOct. So possums are home bodies, they don't tend to travel that far, so we've left a bunch of possums in this coastal exclusion. We've got most of the possums out of here. We've had one detection here and one detection here. So if you think of those two detections across that grid, that's right, that's the possum. That one is this guy here. It's probably quite lonely, I think. And you can see the date here, these are American dates, the cameras do that, but that's the 21st of the 9th, so that's a month after the 28thOct, so it's quite, and that's kind of what you expect in a predator control operation rather than an eradication operation. So looking at these charts again, you can see that in that coastal exclusion we're still picking up a few possums a day on the grids most of the time. In the non-treatment, same again, they like the baits, so we've got this little pick-up of detections here. This pick-up of detections here is really interesting. That's the pre-feed was on that day about there. And so I think you've got a lot of possums scuttling around on the ground who bring up the pre-feed, which makes them more available to take photos of on camera. And then you can see over here, these are those two detections that we had. So we've seen both on those cameras, one possum once. Yeah, so that's cool. Kiwi. So, kiwi pretty widespread across the blocks. Unlike possums, they don't seem to care about being on the tops in the wet and cold. They're obviously reasonably well evolved for it. Yeah, and you can see again in the non-treatment, there's more kiwi there for the operation. It must be a slightly better place for them. And I'll point out here that this is that same 3.5 month period. If we jump over to post-op, this is a 6-week period. So you can see we've got, when you flip between the two, we've got a few cameras that we picked up kiwis on before the op, but we haven't picked them up after the op. And you could jump to the conclusion that we might have got rid of the kiwis in those areas, but it's actually, we haven't looked for very long compared to pre. So I did get asked to clip the pre-data so it was the same time period, but I decided I didn't want to do that because we shouldn't be changing the pre-story after the operation. I just want to kind of update you as you go so you see those pops fill in. The reason that I can come to that conclusion is if we look at these charts here, so this is before the number of kiwi in those groupings per day, you can see that there's a slight upward trajectory in the coastal exclusion, the control is just sort of chugging up, and then the treatment is pretty flat. Yeah, it has a slight down there, but I don't think that'll last when we get the next 2 weeks or months of data. The end point of it will change, but there's a negligible effect on kiwi, and that's what we expect. Doc's monitored a lot of kiwi through 1080 operations. I've recently been involved in a big study in Caribbean National Park in the Paparoas looking at the effects of 1080 on great spotted kiwi. There's been about 5 or 6 operations spread across that study, and we've ended up with hundreds of kiwi monitored through 1080 ops, and none of them. So they're not susceptible at all. So that's cool that we can show that in a different way because radio tag studies are really expensive. Cool. So what's next for us? We've got the rat grid data coming. We're almost ready to release that data. I've processed it all. There's over 800,000 images from that data set. And one of the pulses of aging. The rat cameras are a bit different. They've got these little mayonnaise dispensers that just slowly dispense mayonnaise at a fixed rate each day. And it's the same reason. We're not trying to make a story that there's more rats out there than there actually is. We just want to increase our probability of detection. So when we remove most of them, we're sure whether we've got them or not. So we're looking at trends. We're not looking at numbers of rats. So that database is getting peer reviewed at the moment to make sure I haven't got anything up. That's a huge data set, and I just want to make sure, because you can put a comma in the wrong place and things wrong. So I just want to be sure that that's good before we come back to you, but I'd be expecting that soon. Cool. So the other thing that we're about to start working on is looking at the individual ID of cats based on their markings. We've got a lot of photos of cats from before the operation and non-treatment, and the NET team's done quite a bit of work into seeing if this method can work, so that we could tell a story like, there was between 10 and 15 cats on the block before the operation, or 60 to 70 cats on the block before the operation. So we're going to have a go at that, and I'm excited if that does work, about the kind of reinvasion stories we might be able to tell through that monitoring about whether we're seeing the same cats coming in. So luckily for us, there's not a heap of a lot of black cats, because they are not easy to tell apart. In fact, if they're the same size, you can't. So that's one thing we can't do, but there's lots of these quite interesting looking heavy markings. So that's going to be an interesting piece of work coming up. I'm not quite sure what it's going to deliver, but we're going to have a go, so we'll see how we go. So what's next for the native species in the OCT area? So Pukenui should have a breeding season free from the effects of feral cat predation, which is great for them. And Jen's going to talk a bit more about how we're going to measure if that's been successful for them over the next year. And I thought it was also worth pointing out just some of the other critters that might do all right out of this OCT. So we've got a big brand new mast coming this summer. I don't know if some of you have probably heard about that, but you're probably starting to see the tune-ups on the remuneral trees, and the carpet ball one from Waiho should have a good season. We've got a bunch of other parrots on the island, so we've got kaka and kakariki, so they raise their chicks on remuneral fruit, so they should be able to nest pretty safely. And then we've got a few other species that are present on the operation where you're allowed to use small hawks, tomtits. We picked up some kiti on the cameras, and they should have a good time as well. That's the end of my talk.
Learn something when I listen to you talk, so thank you. So I'm here to update you guys on the progress of the Pukenui breeding season so far, and to let you know how our trapping work is going. So I'm presenting because most of our Pukenui rangers are out in the field as of today, or have just returned. One of them has just come back from the field. So here I go. So as you know, Pukenui breed on the open alpine tops of Rakiura, and they don't all breed in one big group. So as you can see, they're very widely distributed, and they're also cryptic breeders. So nests can be found from Hananui in the north all the way south to Smith's Lookout. There's an estimated 3,500 hectares of suitable Pukenui breeding habitat. And they breed between September and January each year. So right now we're in the middle of their breeding season. So currently we run a trapping network to protect the areas on the map shown in blue. So that's Rocky Mountain, Mount Rakiura, Hill 511, and the Northern Tin Range. Our trapping network currently consists of 190 lake hold traps and 280 kill traps. So the orange areas are not currently protected by our trapping network. But as you can see, some of these sites, luckily, are within the aerial control zone. But you can also see that the northernmost and the southernmost breeding areas remain unprotected. So in past years, the team has only found nests as they've walked past them while servicing the tracking network, plus nests found on a one-day survey that we undertake, and that we call the Outer Nesting Area Survey. So this means that we have had knowledge gaps around what's been happening in the orange areas of the previous map. So this year we have additional funding from the International Visitor Levy, which has been put toward boosting the nesting survey effort for the protection of, for the Pukenui project. So we're standardizing the search effort across all potential breeding grounds to get a more robust understanding of Pukenui breeding patterns. And this will help us in the future to make decisions about where the most important breeding areas are, and then make choices on where we want to expand our protection to. So the nest searching is undertaken from September to December and will be for the next 3 years. So the aim is to search each area twice in a breeding season, and so far this season the team have searched Hananui, Little Mount Anglin, the Paps, Doughboy Hill, Adams Hill, Mount Rakiura, and the Northern Tin Range, including Table Hill. So the team, as they go about the nest surveying, read the behavior of the Pukenui. This helps them locate the nests in environments like this. This is up on the Paps. So the birds will try to catch the rangers' attention, lead them away from their nest, go in the opposite direction. So rangers are always careful of where they step. As you can see in some of my future photos, they're pretty cryptic nests sometimes. Once they're located, the rangers take a quick photo and a waypoint before backing away from the nest site. And once rangers are out of the way, Pukenui quickly settle back onto their nests. And there's the Paps. You can see the green lines there where the teams have searched so far. And they found the nest in the video with the 6 eggs. And yeah, I don't know if you can see all the little lines. That's where the team was out exploring on the Paps. So this nest with the 6 eggs, it's likely that 2 female Pukenui are sharing this nest. It could be a nest of 6 infertile eggs if they've paired together, given the shortage of males in the population, but it would be great if the females had mated with a male prior to laying these eggs. So it would mean that there could be some potentially fertile eggs, but we won't know until our second nest search of the Paps to check its progress. So here's a look at the top of Little Mount Anglin with Hananui there in the background. Bit of snow up the top. And again, the green spaghetti there shows the search effort here. So the team found no Pukenui or nests on their survey of Little Mount Anglin. So it was quite chilly up on Hananui during the first nest search of the season. And the aim was for the team to camp up there to save having to walk up there twice, but the tents had a different idea. So both the tents broke up almost immediately in the gusty conditions, and they had to walk up twice. So you can see again the green where they've searched here. So no nests or Pukenui found on that survey of Mount Anglin. So the team had more luck on Table Hill. 3 of the nests were found in this northern section of the Tin Range with a total of 8 eggs. So the team, in summary, have found a total of 8 nests with 25 eggs across all the sites. So you can see them here as orange dots on the map. This is similar to last year, so by this time last year we found 8 nests all within our trapping network. The extra nest for this year was found on the PAPS during the nest survey work, so we didn't search there last year. But we have to be careful when we're comparing years, when we've been putting a lot more effort into nest searching this year compared to previous years. It's not a fair comparison of the results. And basically what we're looking at with the nesting surveys is a little bit different than breeding success overall. So with the nesting surveys, we're wanting to fill in a knowledge gap that will then allow us to decide where to next put our effort in, like where's the next priority site to expand to for the dotterel protection, while the flock count gives us a more population-based estimate, because while they're up here, they're very distributed, as we've seen, and then in February and March, they all flock together here and over across that Aotearoa. So that's when we have our flock count in April. So now I'll update you on the progress we've made with our ground-based predator control work. So we haven't stopped any of our trapping, and the team have caught 18 feral cats since May this year. That's kind of their Pukunui year, starts in May. And our feral cat catch rate has dropped following the aerial operation. So if you want to be able to catch a feral cat, Rocky Mountain is the kind of feral cat hotspot for trapping at the moment. So since the toxin drop, we have caught 1 feral cat on the access track up to Table Hill, and 5 feral cats around Rocky Mountain. But the team have not seen any fresh feral cat sign within the aerial control area since the toxic bait was applied. And I'll just go into a bit more detail. So here's the location of the feral cat that was caught within the operational area. That's where the star is there. And it was roughly 1 month after the toxin application. So the cat was a small female feral cat, and it was caught in a kill trap on the Table Hill access track. The feral cat wasn't seen on any of the trail cameras on this track, so we're not exactly sure where it came from, but I'm quite pleased that it's dead and that we caught it. But like we've been talking about, it's a suppression operation. It's not sort of an if the cats will come back, it's a when. And so we're really interested in keeping an eye on those trail cameras and that monitoring. And every single round, like you say, will tell us more and more information and give us sort of that feral cat reinvasion rate. Here are a few photos from the nest searching work. So you may see signs like this around here. So we're trying to include some citizen science in the Pukunui project, and we've installed signs at dotterel breeding sites that trappers may visit so that they can report back on any Pukunui sightings and that they can do that accurately. Oh, this is just a kiwi hanging out in the snow. Just up on Honolulu on the 2nd of October. Just a nice shot to show you guys. And the next step for the Pukunui project, so we'll continue on with our usual trapping regime. We'll continue the additional nest searching work until the end of December. Once most of the birds are off the mountaintops and down at their flocking sites, then the team switches focus to banding them through February and March, and then the annual flock count will take place in April 2026, and that's where we'll be able to get an idea of how successful the breeding season was. And I'll hand back over to Darius to kind of wrap us up.
So yeah, we just wanted to put a couple of other things out there And I'll get on to some of the monitoring that we're doing just briefly at the end here, and some of the things you can expect to see, because obviously tonight we're not delivering all of the results, but we are trying to get information to you about the outcomes as quickly as we can. So as you've seen, the DOC team have been out there looking for pukanui nests and spending lots of time wandering around to do that. Service tracks, our team have been out there looking through our camera network, and while they're out there they observe lots of other interesting things. And one of our team found this recently, and it was another good reason to talk about why we're doing this, because this talks a little bit more to forest rather than just animals. And what you're looking at here is an image of a rat nest, now abandoned rat nest, probably because those rats are dead, near the Doughboy area. And what you're looking at is around about 250, by my count 300 maybe, meadow seeds. So these are seeds that have been picked up by the rats, taken to their nest and consumed. So these seeds have no chance of propagating. They've been fully consumed by the rats. And a meadow seed takes around about 18 months to 2 years to basically germinate. So these ones will not do that. Also in this nest, there are a few other things in there, like native snail shells. So they're getting predated on by rats as well. I know people don't get super excited by snails, but you know, they are being harmed by rats as well. Meadow seeds, you know, it's difficult to understand how the forest can sustain itself with that level of seed being predated on by rats. Meadow seeds are important food for kiriru. Kiriru also love them, and kiriru are one of the few birds that we have that can actually consume and digest a meadow seed so that it gets spread around the forest when they excrete it. And if you want to read more about seed predation, you know, there are a few studies out there, but there's quite a good one by William Hurst and Carpenter from the New Zealand Journal of Ecology that actually looked at seed predation in Fiordland, so not too far from here, and looked specifically at meadow seed predation. But we can sort of only imagine the impact that is having on the forest. We've looked a lot at possums, and you know, possum browse is very obvious. You know, you can see when a tree and its leaves have been eaten. This is something that's a little bit more unseen unless you come across one of these nests and look through what it contains. We touched on this a little bit, but this is a bit more detail about the rat monitoring that we're doing in our eradication trial area. So we have these 3 rat grids, 525 cameras across those 3 grids, looking specifically at rats. And our team go in there and take the images off the SD cards, and we're starting to process all of those images. And we want to get down to the species of rat. So in our eradication trial area, we want to know which species were there before we started, and of the remaining rats, what species they are. And that information will be coming once we've processed it. And we touched on this a little bit, but we've also got these deer grids out. So we've got a deer grid of 80 cameras in the deer repellent area there in Doughboy. We've got an 80 camera grid for deer repellent in the standard bait area, and we've got a control outside of the operational area looking for deer. We put these cameras as much as we can on what look like worn game trails. They're not baited, but they can obviously see moving animals passing through them. Now, all the camera data from these cameras gets taken and will be given to Manaki Whenua, who will do the analysis, which will essentially tell us what has happened with deer across these 3 different locations, and to what extent the deer repellent that we use in the operation was an effective tool or not. And that's something that will be coming in the future as well. So to give you a quick summary, what we have shared today is that we've had a really good result on cats as far as we've monitored. We've had a really good result on possums. We're starting to gather the rat data from the Pukenui operational area. done the Pukanui nesting surveys, or started that as Jen has said, but then after that we do population monitoring of live birds and the flock counts after the Pukanui have finished nesting. We'll have the deer camera monitoring coming from those 3 sites. We'll give out some information about bait and carcass degradation. We also started doing testing with Cawthorne Institute of how 1080 behaves in saltwater. There's very little information about how 1080 behaves in saltwater. That was one of the things that contributed to us having a buffer within a coastal buffer within our operation. There's a lot of information about freshwater, but we thought it would be good to get some information about saltwater. We'll have detailed rat monitoring coming from the Eradication Trail area, and we're continuing to do some work on biosecurity. And you might have seen this if you've got the ferry recently with detection dogs, just starting to understand a bit more about the likelihood of rodent movements with freight and passenger luggage, and also an opportunity to talk to people about that while we're there at voluntary trial. So those things will all be coming in time, roughly in this sequence that I've laid out here, and we will start releasing things as they become available. We won't have a meeting for every little bit of information that comes out, but we will be back to talk about more of the monitoring results in future. And yeah, hopefully more good news like the result we had with the text on Pukanui and the fossils. So I'll pass back to Tane, and then we'll start a bit of kōrero and Q&A.
Thank you, Darius, and thank you to the other speakers as well. So yeah, now's the time to open up for any questions. I'll be the roving mic man. Anybody got any questions? Here we go.
Yeah, thanks to that everyone. Dale from Rakiura, based on the island here. Darius, you were just talking about your plan, what's next. We've got a sort of a timeline on what you're thinking there. Just because I'm just sort of wondering, are we going to be heading towards predatory Rakiura, or are we likely to see another poison op carried out for the Pukanui as an interim measure to ensure that we're going to get with it? Just wondering how we're going to.
We don't have an operation planned at this stage. So what we want to do is understand all of these things really well as we can. So we know which tools are being effective, what adjustments we might need to make in the future. So that's really important to do that work before we take another step. I think that, like I said, it's roughly in this order. We think that the rat monitoring, the deer camera monitoring we will have this year. The Pukanui nesting, you've already heard a little bit about that, but the population monitoring or flock counts we won't know until next year, until that's done in April. We'll also know a bit more about the bait and carcass degradation. We actually started that as soon as we finished the operation. I didn't really talk about that, but simply we put carcasses in the environment and monitor their decomposition to understand how that's gone since the operation. Maybe saltwater testing would be pretty close, I'd say. The detailed rat monitoring will take a bit of time to identify the different species of rat within the camera imagery we have.
I'll add to that. Yeah, so that's a really good question. I guess I'd like to add too that I've showed you what the cat situation looks like right now. If that looks the same in 2 years, we're not planning an operation. If it looks like cats are entirely back into the block in a much shorter time frame, we might be considering another one. But then you've also got to add in the Pukanui flock count. So if we make, I'm sure this is impossible, but if we made 100 birds this year, that buys us time as well. So it really depends on that combination of when we start seeing cats coming back into that central area and the results of the Pukanui flock count. So we will have a pretty good idea of, what's the next season will be looking like when we get the results from March from the cats. So we'll have another 2 runs of cameras by then, so November and March, and then we'll have that Pukanui flock count straight after that. So
Okay, good evening everyone. Thanks very much for the presentation again. I would have liked to have gone into a bit more information on the monitoring and understanding how you make your decisions. It was good to have the information prior about what you did. However, there's been very limited time to get behind the information. I have a whole bunch of questions. I know I'm not going to be able to ask them all, but a few things that interest me are, I'd like to know, if I could ask a couple of questions here, please. On the dotterel, could you please tell me what work has been done on the genetic diversity of the dotterel population at the moment, and how many male and females there are?
Yeah, so we have a count of male and female because pretty much every bird is banded now, bar maybe a few adults. So the team can tell the male, female.
Can you tell me the number, please?
I don't have the number in my head.
Okay.
Does anyone have it in their head? We could look it up and get it to you.
Yeah, I would.
26, was that male or female? Male. 26 male in the 105.
As of last year's count. Okay, so I'll put something in writing. I'd like to know what the trend is at the moment. And in terms of the genetic diversity, you've taken blood samples? Yeah. Have you guys analysed the genetic diversity? Because my understanding is a smaller gene pool is more vulnerable compared to a group of population that has a diverse gene pool. It's something I can put into a letter later, but those are important questions because no matter what you do out there, if you're going to have low genetic diversity, it's going to, you know, what does the future hold for these birds, okay? The next thing I need to ask, and then I'll pass on to someone else, but have a few more questions. Where there's been something that's been pretty big at the moment for all of us, after the second toxic drop, September turned into custard, and nearly every single day we've had either high winds, rain, and cool temperatures, shocking weather. I do a lot of kiwi spotting out there, and I know that these birds tend to be a little bit more reluctant sometimes when temperatures are low and they're breeding. I sometimes am really concerned about monitoring data and how you factor in other considerations like weather, like rainfall, like temperatures on the incidence of different animals and what's out there, what's moving before and after. I don't see that in any of the information you're giving us, and why not?
I think that's a question for me. They're all things that when you do a more detailed analysis, you might add in to the analysis. That's reasonable. I guess the whole point of having a non-treatment site is to kind of deal with that. So when you have a non-treatment and it's subject to all the same conditions that the treatment site is subject to. And so when you see a change in the treatment area and you don't see it in your non-treatment, you have more certainty that that's a result of your management rather than some other external factor. So that's the power of showing the non-treatment data against the treatment data to kind of deal with those sorts of things. The kiwi one's really interesting. I said in the talk earlier that I expected to see a dip in kiwis prior to the 1080 operation because they're starting to nest, and when you've got one bird incubating all the time, I would have expected to see a drop off in their activity, but we didn't see that, so I found that quite interesting.
Well, they take about 30 days to form their eggs, so they may not be incubating eggs in July and August, early August. It just depends year on year and what's happening out there.
Yeah, but those results go through to
after
2 weeks ago. So.
Yeah, but there are some pockets out there. I've got your maps that concern me as well. Okay, I'd be interested. The other thing that I really want to point out, and this is, why are you choosing coastal areas where, in all the years that I've been out there guiding, I know that there is a higher density of animal life around marginal areas or coastal areas than there are inland. So by actually using coastal areas, you're going to increase the incidence of pest predators or whatever. Yeah. Why always coastal areas?
Well, we've got, I guess I'll refute that a little bit. Like we've got cameras running from the coast all the way to the middle of the island, and one of the reasons I think that the number of kiwi in the treatment area is lower than non-treatment is because that non-treatment area is more coastal, it's more productive area, so it's like what you see. But yeah, that's once again like our treatment versus the controls. You can see the trend over time. You shouldn't be looking at the number of animals on those charts. You want to look at the trend over across that period before and after the 28 operation. It's you do your best to match your treatment and your controls, and that was our best guess from talking to people on the island about what was most likely to be similar, and it is a little bit more productive, but the fact that there's no animals afterwards for the species has nothing to do with weather or anything else.
Yeah, but there's changes in behaviour as well, week on week, as the season progresses as well,
Yes.
and breeding as well.
Yeah.
So when you're out there bird watching, you're going to see fewer birds out there when they're nesting compared to when they're not breeding.
Yeah, and that's the treatment control thing, because it's the same cycles in both sides. So that's
Yeah.
why you always do that. Yeah.
We're trying really hard to find things. We want to determine whether things are still there or not, if it was a target species. So we are looking for them. We're not hiding from that. We're trying to find if there are still cats in our treatment area. We're looking really hard for rats.
Yeah, but
We need to understand how effective things are, and that's the only way we can really do it. And I think when we started this group, people were very concerned about kiwi, and there was a lot of people who asked us, will the kiwi be okay? And we thought it would be important. Kiwi are an icon bird. It would be important to show people that kiwi are fine after the work that we've done and the operations that we've done.
Thanks for that. Can I just have a question? I was just wondering, we've talked about monitoring of various non-target species, so you talked a little bit about deer monitoring. You've talked about the kiwi monitoring, and I found it quite heartening to see the kiwi numbers, even if it's counting encounters rather than individual birds, that's still a lot of too many encounters across the area for it to be the same kiwi. That's still a healthy number of kiwi, to me, I would estimate, based on monitoring work that I've done with little blue penguins.
kiwi are different.
I also agree that it is a concern about the weather, but it's also it is a time of year. September, August is a time of year when kiwi are starting to emerge less. If they're on eggs, if they're incubating eggs, presumably somebody has to be sitting on the egg. Although I wonder if the parent who's out foraging is increasing their activity in a sort of a compensatory measure. But my question actually is, what is happening with the lizard monitoring?
So there's a guy on my team doing the lizard monitoring, James Reardon. He didn't brief me on that question, but there is, and I hope I get this right, they've started looking at, Nathan might be able to they're looking at the diet of rats around the Harlequin eco populations to see what it is before any management happens, and they want to compare that to what might happen afterwards. And so they've set up, not in the footprint of the Pukanui for one of their sites, and then the other one's at 511, which is in the footprint of the Pukanui. Is there are they monitoring the geckos as well, or is it just the rat diet?
Yeah, they're monitoring both, and they're also doing market capture, I believe, as well, so photo IDs of the stinks, and from that you can work out the survival rate over time. But that data for the survival rate should need at least 3 seasons of data, or 3 capture periods to get your survival rate. So probably year 5 of the work, they'll get better results than in year 3, because the data gets better as time goes on. So previously with that sort of work, like potato stinks and the green stinks up on the raised flat, they could show the survival rates across the adults and the increased recruitment as well. So it's really great data, but it's really labour intensive as well, because you manually got to go through the photos to do the IDs. And all the stinks and geckos, their patterns, they're like a fingerprint, so you can tell them apart.
No, share the space.
Mary Malloy, 104 Runaway, and also South Westland. I've got hundreds of questions, which I won't ask you tonight, but one confuses me. On the one hand, you're saying suppression, this is a suppression operation, yeah? On the other side of the room, it's eradication. So there's a difference between the two. Eradication's being practiced, or trying to be practiced in South Westland, and there's a few things come unstuck there. So is it a suppression or an eradication operation that's underway, and what's the long-term intention?
Yeah, good question. I can see how that confusion has risen. So that two-phase part that Darius talked about, that was an eradication trial, and that trial is to see whether we can use 28thOct to eradicate the threat species of rats. And arguably, well, no, definitely, in my opinion, 28thOct is a lighter touch than Riverficum, which is the kind of established island eradication tool, which is way less palatable for all of us here to use. It's a cumulative toxin. So they wanted to test that. So that's a trial to see if the method will work. So from South Westland, they've tried it on ship rats, and as we talked about, we've got different species of rats here. So that's a test. It's not a like, we're going to eradicate it and defend it. It's just to test the method. And so it's a, I guess it's an experiment, for want of a better term. The larger 43,000 hectare operation, the Bukanui one, that's a suppression operation. So that's us kind of giving Bukanui a lifeline from cats. There's no intention to defend it. And it's worth pointing out that the massive cost difference between a suppression operation and an eradication. So my job for the kind of wider 28thOct program is, it costs you, how do I describe this? It costs you a heck of a lot to get the last 1% of animals when you try and eradicate, and it doesn't cost you that much to kind of get to the 99%. And so for DOC across the country where we can't defend our areas, we do suppression operations because we're not chasing those nasty animals. But we are chasing the easy wins to get things to last as long as possible. So that's the difference. So the Bukanui is suppression. We're waiting on the results from the eradication trial, and those results will guide you to. So I'd say it's all up in the air really, isn't it, until we see what the results are. We don't know.
So you're likely to carry on and eradicate like they have in South Westland, like they try in South Westland?
Depending on the results.
Yeah, I mean, we did the eradication trial, and just to explain it, because I think it's good to get this out here for everyone. So the first application, we'll just talk about the toxic application and not worry about the pre-feeds for now, was 4 kilos per hectare in that smaller 7,000 hectare area of the Rakiura Valley, roughly. That's a hard number for people to really understand, but what that means when you walk through that is you're probably encountering a bait on the ground every 2 metres, would be my rough estimate, if you walked in a straight line. It's quite a lot of bait on the ground. And then because that was inside the bigger Pukenui area, we went across with a second application over the top of the same area of 2 kilos per hectare. 2 kilos a hectare is a bit less, and you're probably encountering a bait every 3 to 4 metres when you walk in a straight line. So that area has been treated twice, which is something that we would do if we were attempting eradication anywhere else. The issue we've got with this particular area is just with that, we probably won't get all the animals in there. There'll probably be some survivors, and that's why we want to understand which survivors are still there. And also, we want to understand what other methods we would have to do if we were going to go back and get those. Now, we won't be doing that in that trial area because we can't defend it. There's no boundary, there's no river, there's not on the coast. So it really is about learning what an eradication method does in this environment and
what we might need to do or change for the future.
So your long-term plan is probably to eradicate, is that correct or not correct?
Yeah, we're trying to get Rakiura predator free, that's the goal.
So suppression is not really the word to use. Suppression is only part of your operation. Eradicate is what you're aiming at. Is that correct?
Yeah, the suppression was to buy us some time in the Pukenui breeding habitat, so we didn't lose the Pukenui.
Okay. I just do have one other question. The geckos that were discussed, well done. You know that it's going to take several years to get a proper population idea. Why have we gone into these operations in the July, August time without getting an idea of what the population was on the island, particularly in view of the fact that really you are going for eradication long term if you can get away with it? Do you want me to make that clear?
No,
No, it's a good question.
it's a good
We're just
question. That's
figuring
quite
out.
clear. I'm just trying to think how to answer it. All good questions are hard to answer. Carefully. It'll take me longer to answer. So I guess the suppression operation, the Pukenui one that we're talking about, so we do have a good idea of the number of Pukenui, that's cool. So that's the reason for that. Yeah, and we're not marching forward with an eradication anytime soon, so we have got time to kind of build that knowledge around geckos. So I'm not too concerned about that.
I'm not meaning just geckos, I use that as an example of what appears to be a pretty good scientific program.
Yeah.
Why can't we do that for all the species? Because you might be surprised, like I know there's still mobile on this island and they're still nesting and they've got themselves quite well established.
Oh, can you tell me where they are?
I don't know.
Oh.
Because, I don't know because you guys don't have a great reputation. Don't mind. My experience is that destruction follows information. So I'd have to be very careful about that.
Yeah.
But that's only one.
Yeah.
So I don't think that there's been enough work done before poisoning and like, for God's sake, don't call it a treatment, it sounds like something benign, it's a poison.
Yeah, totally.
Yeah.
Yeah.
No antidote,
Yeah.
no taste.
I guess
No
my reflection on that is, I've spent a lot of time in areas that have received a lot of pest control with over the years and areas that haven't. And I've watched populations of birds go extinct in the name of science when you're doing these non-treatment studies. You go right over, this is where we're going to live in Canada, this is where we're not, this is where we're going to monitor the birds, we have a mouse come and then your non-treatment goes extinct, and it's pretty crap to watch.
It's pretty crap to watch what happens after a drop, followed by another drop, followed by another drop.
Yeah, so my experience in those situations is we are maintaining those birds and we're actually seeing increased populations. So I guess we've got quite different experiences, but...
Okay, I'm prepared to share them with you. I'll invite you to a place where there are good birds, where there hasn't been genetic.
Yeah,
they
exist.
And
yeah.
I'll show you next door where there has, and it's not the same, but the distance by birds wingers are not very far.
Yeah. I guess my experience from running around doing all those camera works is the bird life, with the exception of kiwi, is it's pretty poor on that western side in the Dover catchment. Like, I was pretty shocked about what's not there anymore.
Well,
it's so...
do you know what was there before you came? Before the drop?
Yeah, because I put all the cameras in.
Yes.
No, before
How long
then.
ago?
When did they go in? It was in the beginning of May.
Yeah.
That's nothing.
It's only a matter of months. Like, you need several breeding seasons in order to get any idea of what's in an area and established and doing well. Haven't even established for the Pukenui, but why did they pick such disgusting places to have your children? They don't in other parts of New Zealand with a slight variation of the species, do they?
Yeah, well, I guess it's worth pointing out that Pukenui used to be all over the Southern Alps of New Zealand, and they're not anymore, so, they've been pushed here.
Well, the question is still, why are they here? Why did they leave for someone else? And that's not established, it's assumed. Like, I don't want you guys to assume anything. I want you to spend several years establishing actually how things are, what the benchmark is. I really feel that I know you've done a lot of work. I can tell you've done a lot of work. It's going to be very hard to question you because there's so many of them, but there's just so much detail that has not been gathered before everyone's gone and said, we know how we're going to 1080 it. Because a while back we didn't know how it's going to be 1080. You'll use Board of Come too because you've stuck that old with it. I mean, loosely your organisation, not you specifically. So for me, it is really a very poor situation from science point of view to just come in, drop stuff, throw some cameras out, drop stuff, and then say how it is. Like if I caught a young female cat and I wanted to get rid of cats, I'd go looking for kittens because there'll be some there and percentage of them will survive. If that's an issue. There's just so many things that concern me. You stated that you use rabbit bait to lure cats in, so the bait is poison? No, it's just a lure. You're just using it as a lure. It's very hard when people use the term bait because it can be poisoned or it can be used as a lure. If it can be used as a lure, go that extra 5 seconds and catch it. Like cats are relatively easy to catch. Relatively easy.
I don't reckon.
Oh, I can get cats without stepping very far away from my house. No problem.
We need you on the Pukenui team, Mary.
I don't like that. And I wouldn't disturb their nests, I couldn't stand it. But thank you for that.
Sorry, thank you. Does anyone else need to ask a question?
Yes, please.
Yeah, can I just ask mine before I ask yours, because I know that you're whatever, okay. Deeply concerned about the lack of monitoring and the lack of time frame in which the monitoring has been done. You can't call yourself a scientist. Scientists take years to actually look at things, ask multiple questions, look at all the variables. So it's really important. There's a lot of people in this room that may not ask questions, may not think of the questions to ask. And it sounds like one great big experiment and lots of assumptions and lots of information. So we know that poisoning is taking place in other parts of New Zealand, but we're still an experiment. We know that poisoning is taking place in other places, and we still need to find out how the cats are going to behave, okay? So lots of concerning information being given out. What I need to ask you is this, a couple of questions. How often is the rabbit bait or lure replaced? It's one of my questions. How often was the rabbit lure and the scent, rabbit scent, replaced?
Yeah, so I talked about that. It's when the cameras went out, it gets replaced, or put out, and then 2 weeks later we come back and replace it. So we refresh the lure, the rabbit lures, and refresh the bait.
So every 2 weeks?
But every 2 weeks for 1 month. So it's deployed, it's changed, and then we leave it through to that next baiting period, which is 3 months later. So we don't.
So only for 1 month?
It's 1 month, and then the cameras run effectively unbaited or formally baited through to when you get to the next round, which is 3 months later. So we've done the pre-stuff, we've done a post-survey, which is the 1 month. We went back and picked it up again so we could tell you the story, and then we'll be back at the beginning of December to redo it. And so another month, cameras again over Christmas, and then we'll be back at the beginning of March to do it again.
All right, you need to slow down because I'm not as quick as you. So you put down the cameras, and you put yours in at that start, and then 2 weeks later for a month.
No,
So
2 weeks later we changed it.
Yeah.
So
Each 2 weeks for a month.
So you put it out, you change it, and then we assume that the bait's gone 2 weeks later. So we were saying that we refresh it for 2 weeks. So it's a month of the same amount of baiting, and then we don't pull it in, we just leave the cameras going.
So no more lures.
No more rebates, and then we come back 3 months later and we do it again.
Yeah, I'm just trying to understand your monitoring information and the charts you had about when you started doing your monitoring and the changes that took place from after the poisoning. So are we saying that the cameras were still working through that time?
Yeah, that's how I had a line on the chart that said this is the
It's
date
still
of operation.
working, and they weren't lured after a month.
The lure from the last survey was still there. And then 1 week post-op we came in, we rebaited. 2 weeks after that we rebaited
Alright.
again.
I'll put something in writing, and I want to get a bit more specific information about that, if you don't mind.
Yeah, sure.
Okay, can I just ask one more question? You mentioned something about it's going to be a mast year for emu.
Yep.
Okay, how do you arrive at that?
Just go and look at a female tree and you'll see all the tips have turned up and there's little seeds starting to develop.
I see that over many years, yeah, and I've been guiding you for a long time. And I think in all that time, there's only been a few years where there's been mast years. There was one a few years ago, and that's why we had an explosion in rat population. That's why Ulver Island was, Bredivcoon was dropped on Ulver Island twice a couple of years ago. So you don't have mast years usually a couple of years after a previous mast year. So mast years are used as an excuse to drop poison again and again.
Okay,
And
well,
it's
let's have a
concerning.
chat after
I
this
will.
summer and you
Yeah.
can tell me if you're right or
I
not.
will. Yeah.
Yeah, that's cool.
Thanks. Still turned on. Great. Couple of questions. Sorry, I'll keep it pretty quick. I realise that the agriculture industry on Stewart Island got behind this, and hence that's why there's the buffer zone put out there. Was there any monitoring done around that coastline to see if there's any effects from the poison drop, or is it not required?
I guess it wasn't required because we did the buffer from the coast that Darius explained, so. But there was you freshwater sampling in some of the rivers?
Yeah, about the water. Yeah, so we did do water sampling from the Water River and Rakiura River. So that was done. And as we know, 1080 dissipates very quickly in water. We did put those results out to the community here, so we did get a little detection in the Pukanui operation on both the Doughboy and the Rakiura, but within 24 hours it was well below the detectable levels. Yeah. And I did just want to touch a little bit on pre-monitoring as well, just because we do have years and years of information about Rakiura from lots of other sources. So, and most of it's pretty bad news. So Kakapo got to very low numbers and had to be evacuated to Whenua.
That's not what
That's rubbish.
Ground-based science.
Saddlebacks were almost gone, and they are now present, fortunately, on Ulver Island because they were rescued from other offshore islands.
Reduced to 27% after you pulled Littleton. That's not really a good stat.
Yeah, but
Don't
I'm just
go
saying
down the street, it's ridiculous.
there is lots of information that points to predation being a major contributor to species decline here in Rakiura. And what this work is doing is starting to reverse it. Because we think there is an opportunity to save species from going extinct, and there might be an opportunity to bring some of the species that can't survive on this mainland island. At the moment we want to bring those things back so they've got habitat to live in. That's the goal. That's the information that we have, that things have been in decline for a long time, and if we don't do something about it, it'll continue to decline until they're all gone.
Just my other question, just before I gotta go, because I've got to head home. I'm not sure if you're going to put out there the total cost of the operation, but I'm just keen to know, is there a significant cost difference between using the deer repellent bait compared to just using bait?
Yeah, it costs more. I can't tell you exactly how much more.
I was told $37 million extra.
37 million.
Yeah, extra to use
For
deer
that
repellent.
job?
No.
To use
Across
deer
the whole
repellent.
project.
Oh, right,
Yeah, 37 million.
To give you a rough guide, it is about 30% more expensive per account. A rough guide. Again, depends on how much you're using, where you're using it.
Let's press a button. Should all go. Yeah, I'll try. Just two questions I've got. And one is around contamination sites of independently monitored 5 different sites in South Westland where there's been gross contamination where the bait is loaded into the choppers. And I'm talking, about 25 mil thick. How did you get around that problem on Island Hill? And the other one is, I'm extremely concerned about the monitoring. I can understand you've monitored some stuff. In South Westland, as you probably know, DOC consider that probably up to 20% of the care get affected by 28. And I know they're doing a lot of work. Now, Kaka is not that dissimilar to Kairos. You're going to say, well, one's an alpine parrot, the other's not. In North Okarito in 2010, they monitored 9 kia, and they killed 7 of them. And that was in low-lyed forest. In that first operation you did, there was 500 black-billed gulls were killed in the Waiho River. And when the question was asked, they said, we didn't know they were there. Now, I'm talking facts here, there is under them. Yeah,
I'll let Tristan talk about the Kia and Kaka. And yeah, we talked about the black-billed gulls before in South Westland. But I think just to talk about the load site, good question. So after the operation is completed, we sluice everything down because we know that we dilute and remove 1080 with water. And we put a perimeter around that load site to tell people not to go there until we're certain we've had enough rainfall to wash it away. The load site, without a doubt, is where you get the most concentration of bait because we've been loading and unloading from there. We do a very significant sluicing down in that area, but we do need it to rain quite a lot to make sure that there is no toxin left in that area. And I think as it's been pointed out already, it's rained a lot, which is a good thing. And it's actually good for the toxin out in the environment as well. We want it to rain after the operation so that those pellets are safe and they break down in the wet conditions.
Cool. Kia, Kaka. You're right about Kia. It's been a really difficult thing to figure out how we can mitigate those risks for Kia. So yeah, it's a big body of work that's ongoing about how we can protect Kia from not only cats and stoves which are driving into extinction, but also from the effects of 1080 operations. So it's really variable, and like you said in North Okarito, that was the result. It was pretty shit. So that's a work in progress, and yeah, it's not a comfortable conversation. And again, when you look at populations of care in some places where there's no management, it's really grim. And then, like you guys have probably observed in some parts of South Westland, they're doing just fine with no management. South Westland's a really interesting place in the beach gap. There's a real up high, there's no masting species, so you don't get these big pulses of predators, so the bird life up in there is actually pretty cool. When we talk about Kaka, we did a 1080 Kaka study around Lake Para in South Westland. There's a published paper on it, I can send it to you. I can't remember. Can you remember how many Kaka we wanted with radioactive exposures?
It was minimal. It really was.
It
It
might
was
have been
around
20?
No, I think it was only about 10 or 12.
No, it's more than that. I remember them.
Well, it doesn't matter. My
Anyway, we've monitored a bunch, there's been a bunch of studies, there's studies from Rakiura looking at kaka, there's a few others kicking around, they don't need a fate, they don't die, we've never had a kaka die from a 28thOct. So even though they look the same, they've still got a big can over on the front of them, they don't touch it. So
That's
yeah.
not true, they
That's
do
not.
touch it, they do die from it, and Rakiura is a perfect example. If you ask the farmers who back onto Rakiura, 3/4 of them are prepared to say that they lost kaka. They had kaka killed.
yeah, well, I don't know what to say about that other than we've put transmitters on a bunch of birds and they're fine. So yeah, maybe it's bad luck, but it's what I go on. I've put transmitters on, I've checked them around before and after the hops. I've watched what happens in the non-treatment when you have possums and stoats nailing their nests, and I've watched what happens afterwards when you go, oh great, we've made some chicks and they fledge. So I've seen it firsthand, some climbing trees I've looked in, I've seen the chicks have been in like as far as kaka go, it's a great story with your navy. So yeah,
Are you saying
you're not going to convince
possums?
me.
No, probably not, but I'd like a chance. Possums, well, I might do it here because
Put a lot of time into those birds. I don't think you put that much in.
Well, you don't know, I'm 75 for God's sake, I've got to put a little bit in.
Yeah.
Do you think so?
What's that?
Do you think I'm going to put a wee bit in that time?
Oh, into kaka?
Into kaka?
Yeah.
Yes.
Yeah, possibly. Yeah. I guess it's the difference between anecdotal accounts and like actually like, you know, properly looking at things and doing the same methods and telling that story. And it's always the battle we have in these things is because unless you're in my position, you can't do that. You know, like it's really hard. Yeah.
And I really get really grasped off when the department draws assumptions because that's the same as anecdotal and properly draws that. Many possums and tartars.
Yeah, that's terrible.
That's one.
I'm getting almost. Yeah.
That's just rubbish.
Hey, look, just
I'll
conscious
send you some videos.
Just
Um,
Yeah, I bet.
one last
There's
question
only one
over
video I've
here,
seen it.
just conscious of the time.
Okay, just a couple of observations. Has drunk too much at work today. Never mind. So one observation is
Just
that
remember though, keep it respectful in the
Yeah.
comments at the start, please.
have I said something disrespectful so far?
Not sure.
That he drunk that wine.
Yeah.
Yeah, that's
It's a joke.
That's not respectful.
Are you going to write a security thing about me? Yeah. Okay. So could I? Yes, I do, Shona. Thank you very much. Yeah, and I didn't spend 13 minutes waiting for people to eat before starting a 7 p.m. meeting. So don't get at me, please. We will be recording this. So a couple of observations here I just need to make. Information is being given out in Kiwi for Kiwi, yeah, that was provided by the Department of Conservation about the Kiwi population on Stewart Island, portraying a really dire picture of Kiwi declining from 25,000 to 13,000, and then in whatever 2030, suggestions that it will go down to 9,000 or under 10,000. You guys haven't got a clue. You're just showing us what we know already. We've got lots of Kiwi on Stewart Island. You don't know the number. So DOC are very good at making up numbers and making assumptions. If you guys have said things that are not correct and not accurate, not true, and misleading, what is the repercussion for you? In statements you've made over the last number of community meetings, because they have been questioned by some of our technical advisors. You know, what is the repercussion for you guys for giving us false information?
Well, it's a hard one to answer. All I can say is we give you the information to the best of our knowledge at the time, and you know, yeah, I can't talk to those numbers because I wasn't involved in the research, but
It's not just about Kiwi. What I'm trying to put through is the fact that we don't know a lot about what's out there in nature. You know, 2 new species of weta were found before we started dropping poison around the place. Do we really care? And yes, weta do die from the poison drop. It's been shown. We've got photographs of dead weta next to pellets, for example. Yeah, you know, the Gollum galaxias found in our rivers and Southland only. Do we really care? You know, someone likened it from Doc to Takahe. Do we really care? And you say, okay, we've got lots of monitoring data, but there's absolutely no long-term monitoring data across a wide spectrum of species, and we keep pushing and pushing for that. You're never ever going to convince us that you have monitored all our species across the broad spectrum, because different animals will behave differently to the poison drop. So we want to know, we do care as much as you guys do, and we're not convinced.
Okay. Time's ready to go. And, cup of tea and then have another feed and then a moi, stuff like that, eh? All good. Look, I'd like to really thank you all for attending this evening. We've all come from far and wide, and to participate in the hui this evening. Safe travels home to Makafiu up that way. Absolutely to the whānau up there. And I'd like to thank our speakers here this evening. You've done a really good job, guys. And to the whānau ka hau kāinga, tēnā koutou, he karakia whakamutanga te hui o kia tau, kia tātou katoa, te auto whai o tātou, aruki a hei o karaiti, i te aranga te atua, me te whihenga o tahi tau, ki te wai o tahi, aki a me o Māori e koutou. Thank you.